Welcome, my dear students. Children, we have already discussed about the basic computer organization in the video 1. This is the video 2 of the first chapter in which we will discuss about the memory unit. You all know that memory plays a great role in the computer organization. Without computer's memory, we cannot do even a single task. So, when we talk about the computer memory, it is divided into two parts, primary memory and secondary memory. Today we will discuss in detail about RAM. So, let's start with what is memory. Memory is something like to retain something. Memory is to save something. So, it is used to store data and instruction. You can assume a computer memory as a many blocks with each block having a unique address. If suppose, as I said that the memory is divided into a large number of small parts, that is called cells. So each cell has unique address with zeros which varies from 0 to n minus 1. For example, I have a total memory of 10 cells in my computer. It is just an assumption. So if I have a memory of 10 blocks in my computer, so my memory addresses will start from 0 to n minus 1. That means the address of the block 1 is 0, the address of block 2 is 1, address of block 3 is 2, 4 is 3, 5 is 4, 6 is 5, 7 is 6, 8 is 7, 9 is 8 and 10 is 9. So my memory addresses will vary from 0 to 9. Okay, so for example, if we have a 64k words, so the memory unit has 65,536 memory locations and they vary from 0 to 65,535. Okay, let's discuss now further about the cache memory. This is the very important part of my computer system. Now, you must have wondered this thing that what is a cache memory? What is a cache memory? It is a high-speed memory which is installed somewhere in between the CPU and the main memory. Remember, it is not a main memory or it is also not a secondary memory. It's just a cache memory. Cache memory is to store the applications which we recently used in our computer. For example, I'm working on MS Word. I'm listening to the music and I am playing one game. So in my cache memory, the computer will store these applications. Okay, so to better access or to have a fast access of all these applications, operating system keeps all of these applications in the cache memory. It acts as a buffer between the CPU and the main memory. So I hope you understand that what is cache memory. So this is the diagram of the cache memory. Now, what are the advantages of the cache memory? Cache memory is faster than the main memory. It consumes less access time than the main memory. It stores the program that can be executed within the short period of time. And it stores the data for temporary use. Disadvantage, it is expensive and it has a limited capacity. Coming to the main memory now, you all know the main thing which is a backbone of my computer, that is the main memory. So we call main memory as an internal memory or primary memory also. But this memory is volatile. This memory is volatile. That means it is divided into two parts, RAM and ROM, and RAM is volatile and ROM is non-volatile. So here we have to understand one more important point, that the memory is not registers which are used in CPU. It is something different from that. Okay, so it is generally made up of semiconductor device. These memories are not fast as registers, and they required data and instructions are processed in the main memory. So these are the diagram of the RAM and ROM. Coming to the RAM, random access memory, the memory in which the data get erased once the power is turned off. It is an internal memory. It is a read and write memory. We call this kind of memory as a read and write memory because why we call it as a read and write memory? Because we can save some data into this memory and we can fetch some data from this kind of memory. Access time in the RAM is independent of the address. That means each storage location inside the memory is easy to reach as other locations. That means we can access location cell 1 at a time, and at the same time we can access the cell 10th. So every cell, every memory location is independent of each other. Data in the RAM can be accessed randomly, but it is very expensive. RAM is volatile, so for this, due to this nature, we need to use UPS with our computers. Now, types of RAM. There are two types of RAM: dynamic access memory, that means DRAM, and SRAM. As the name itself says, that the dynamic means which keeps on changing. I'll tell you the very basic thing about this thing, that the fundamental storage cell in the DRAM are of two elements. There are two elements in the DRAM: transistor and capacitor. Listen, transistor is only used to charge the capacitor. That means it gives the electric current to the capacitor. The capacitor can hold either high voltage or either low voltage. When it is a high voltage, it is 1, and when it is a low voltage, it is 0. So, but this kind of DRAM memory has some problems that we will discuss now. DRAM access times range from 20 to 70 nanoseconds. Okay, let's talk about the DRAM refreshing and storage density. As we all know that we need one transistor and one capacitor per bit. Here I am talking about per bit. So that means if my RAM is of like 512 memory locations, so that means I need 512 capacitor and 512 transistors. So that's why the storage density of DRAM is obviously high. So they are available with 10 to 100 gigabits density. This is just an example I have shown, I have told you, but they are available from 10 to 100 gigabits densities. Then comes the DRAM refreshing. What is the meaning of refreshing? That means to take that particular thing again and again. As we do in the internet, we used to refresh, so we refresh our connection. The problem with the capacitor is this, that it start losing its charge after some amount of time. So that's why we need, the memory controller has to refresh the capacitor again and again. Refresh the capacitor again and again. Sometimes even a read operation. Suppose we are fetching some data from the memory, so my memory get out of discharge. So memory controller has to play a great role in this kind of memory, that is DRAM. So memory controller needs to be refreshed the memory contents as many as 1000 times a second, called memory access time. So these are some characteristics of a RAM. Short data lifetime, uses a RAM, smaller in size, less expensive, less power consumption. Coming to the next part now, static RAM. Static RAM, as the name itself says, that means nothing is there to be refreshed. Whatever we have, whatever charge is there in my capacitor, that will remain there. But here in this kind of memory, we do not use transistor and capacitor both. Instead, we use a matrix of 6 transistor with no capacitor. We will use a matrix of 6 transistors with no capacitors, as transistors do not require a power, so it will prevent leakage. So that's why SRAM need not to be refreshed on the regular basis. There is an extra space in the matrix, hence the SRAM uses more chip than DRAM. Obviously, we need to install many matrices, so that's why the space or the chips required in the SRAM is oftenly high as compared to DRAM. SRAM is thus used as a cache memory also, and it is very fast. So here are some characteristics of the static RAM. Long life, faster, larger size, expensive, higher power consumption. Okay, so that's all for the today video, and tomorrow we will again, I'll come up with the next video, that is on that video we will discuss about ROM. Thank you so much.